today we're looking at lesson 2.1, place the first digit. How can you tell where to place the first digit of a quotient without dividing? Sounds kind of like, so let's see. Tanya has 8 purple daisies. In all, she counts 128 petals on her flowers. If each flower has the same number of petals, how many petals are on the flower? Divide 128 divided by 8. Use an estimate to place the first digit. Okay? So they rounded 128 clear to 160. Why did they do that? Aiden, why do you think they did that?
Because it's like a really easy
To divide into 8. Very good. 16 is a compatible number to divide 8 into. Okay, so the first digit of the quotient will be in the what place? The first digit of the quotient will be in what place? Is it going to be in the hundreds, the tens, or the ones? The tens. It won't go into that number in the hundreds, will it? No. Step 2, divide the tens. Divide 12 tens divided by 8. Multiply 8 times 1. Subtract 12 tens minus 8 tens. Check. So now we subtracted and we only have 4 left. Can 4 be divided by 8? No, it's too small. We can divide 8 by 4, but that's not what we're doing. We're dividing 4 by 8. So check. 4 tens cannot be shared among 8 groups without regrouping. Regroup any tens left as ones. Okay? So they subtracted 8. They regrouped any tens left. There's 4. They brought down their 8. Subtract 48 ones minus 48 ones. Because 6 times 8 is 48. 0 ones cannot be shared among 8 groups. Since 16 is close to the estimate of, what was our estimate back on the other problem? Our estimate was 20, right here. So, since 16 is close to the estimate of 20, the answer is reasonable. So, there are 16 petals on one flower. So, by estimating, rounding our 128 to something that is compatible with 8, we could tell where to put our first digit, right? Because we got 20 when we divided 160 by 8. And we could tell that we either needed to multiply 8 by 2 or by 1. Which doesn't seem like a big deal now, but as your division problems get a little harder, that will be very helpful. All right, you should be on page 62 at the top. Read your little green box. Remember to estimate the quotient first. Use place value to place the first digit 4,236 divided by 5. Use place value to look at the first digit. Look at the thousands place. What's in the thousands place? A 4. 4 thousands cannot be shared among 5 groups without regrouping. Look at the hundreds place. There's a 2. Because the first digit is in the what? So So this is 42 hundredths can be shared among 5 groups. The first digit is in the what place? Where's the 2? Hundredths place. We better do this estimate. What is something that's close to 42 that is easily divisible by 5? 40, or we could make it be 4,000, right? Divided by 5. How many 5s in, let's look, will 5 go into the number in the thousands place? No. Okay. How many times will 5 go into 40?
8.
And then we would have 0. So our answer should be somewhere around 800. Step 2, divide the hundreds. Divide, how many hundreds did we have right here?
42.
42 hundredths divided by, what are we dividing by? 5. Multiply 5 times 8 hundredths. We can get that from our estimate, right? What is 5 times 8 hundredths? 40. If we subtract, we end up with a 2. Subtract 42 hundredths minus, oops, that's the wrong thing. Subtract 42 hundredths minus 40 hundredths. 2 hundredths cannot be shared among 5 groups without regrouping. Okay, so we're going to go on to step 3. Divide the tens. So we have 23 tens divided by what? What are we dividing by? 5. So I'm going to multiply how many 5s in 23? How many 5s in 23? 4, which is what? Multiply 5 times 4 tens. Okay, so they did that. They got 20 right here. When you subtract 23 tens minus 20 tens, you get what? 3. 3 tens cannot be shared among how many groups? How many groups are we dividing it into? 5 groups. Divide the ones. Okay? So now we have, we subtracted and got 3, and we brought down our 6. How many 5s in 36? 7. So divide 36 ones divided by 5. Multiply 5 times 7 ones. Subtract 36 ones minus 35 ones. Then we get 1. Check. 1 cannot be shared among, how many groups are we dividing it into? 5 groups. So our answer is 847 with the remainder of this 1 down here. Okay, so if you're watching this at home, you might need to pause your video because you had to write everything in blue that it gave me. So go ahead and pause it if you need to. Okay, here we are on page 63 with the share and show. Let's go ahead and estimate this. How many 3s in 5? 1. So it's going to be 100 something, isn't it? What could we round this to, do you think? 600, well, that'll give us 20. Okay? So I'll just write that up here. 600 divided by 3, and that's going to give us 20. Oops, 200. You're right. And we'll do our work. Okay, here we go. You told me there was 1 3 in 5. So I'm going to make this a little bigger. So it goes in there 1 time, and we're going to take 1 times 3. We have 300. We're going to subtract. We have 2 left over. Check and see. Can you divide 2 into 3 equal groups? No. So we're going to have to bring down that number in the tens place. Now, how many 3's in 27? 9. See, if you know your times tables, it's very helpful, isn't it? That's 27. We're going to subtract and get 0. Can we share 0 among 3 groups? No. So we're going to bring down that 9 in the ones place. And how many 3's in 9? 3. And so we would subtract and get 0. Now, is 193 close to 200?
Yes.
Yes. So our answer is probably reasonable. All right. This is number 2. Let's do the estimate together, and then we'll let you work it. What could we round 1,035 to? That would be easily compatible with 5.
1,000.
1,000. So 1,000 divided by 5 goes in there twice, right? Leaving us nothing. So we'd have 200 again. Okay, go ahead and stop your video and work through number 2. All right, let's check to see how you did. So we're going to divide 1,035 divided by 5. Now check, 5 will not divide evenly into 1, will it? No, so you can put an X here. How many 5's in 10? 2, which then we've got to multiply. 2 times 5 is 10, and then we're going to subtract, and we get a 0. Now we're going to bring down our 3. Can 3 be shared among 5 groups?
No.
No. So we have to get some more. Now some of you do this, which is fine. Then we're going to bring down our 5. Okay, how many 5's in 35? 7. Oops, we forgot to put a 0 above that 3 because it won't go in there. And then 7 times 5 is 35, and we would end up with 0. So 207. Is that close to our estimate of 200?
Yeah.
Okay, let's estimate this next one. This is number 3. Well, something that's easily divisible by 8 that's close to 17. Ethan. 16. Okay, that's pretty close. Or you could go larger to 24, but that might be pretty big. So we're going to do 16 divided by 8. And it's going to go in there 200 times. Okay, go ahead and stop your recording and work through that one. Okay, here we go. We have 1,766 divided by 8. Now we know from our estimate that 2 times 8 is 16. Is that pretty close to 17?
Yeah.
So let's multiply 8 by 2. We're going to get 16. When we subtract, we're going to get a 1 in 100. Check. Can 1 be shared equally among 8 groups? No. You would be surprised how sometimes kids subtract and this number is larger than their divisor, but they don't think anything of it. What happens if this number is larger than our divisor? We needed to have added another 8, right? Okay, so then we're going to bring down our 6. Will 8 go into 16?
Yeah.
How many times? 2 times. And 2 times 8 is